Good morning. I'm Dr. Manoj Kumar Srivastava, Assistant Professor in CSC Department. And today we will be discussing on the data analytics topic of Unit 3. Actually, it is as it has been displayed on the screen. You can see here. And as we have earlier talked about the data stream, in which we saw that advantage, disadvantages, their use, application, and now we will talk about the application of data stream, where this data stream will be utilized, and what are the different application data stream. And another topic is architecture of the data stream management system. So when we are talking about the application of data stream, these are the activities in nowadays we can see on the internet and different platforms. There are so many application of data, because high volume of data, when we are talking about the data stream, we always talk about the internet as a source, and data that is being utilized on the different platforms, and the activity related to those data which is being involved in the internet platform, those activity will be treated here as applications. Example is fraud perception. Fraud perception is actually referred to the as we can say, I will give you the example that earlier we talked about the credit card. Credit card is an example where number of users being using and utilizing those card for transactional purpose. As we saw earlier, that types of data stream, that is transactional and measurement data. In case of transactional process, the credit card user try to transact for different purpose, either to purchase anything or to do any other exchange process. So there it is possible that credit card fraud can be done. It can be cloned card can be utilized, or also some card can be theft from someone and can be utilized on the network to for their own purpose. That's why in order to identify those fraud perceptions, cybersecurity is another process of that. But in data stream, this data stream also helps to identify those activities which is erroneous activity, or those activity which are very unusual for the particular person that who is using that. That's why fraud perception is very important part here. We can identify those, or we can perceive, or we can find it out what are the fraud activities being going on with the help of this data stream. That's why it is talking about the fraud perception. Another is real-time goods dealing. This real-time goods dealing we are talking, when we are talking, this is treated as application data stream. Why? Because we know that in today's world, there are different e-commerce portals are there, and on e-commerce portal which is on the network, and those network data is being used for transactions process and exchanging the goods on the network, or we can say purchasing, selling and purchasing on the goods on the e-commerce sites. And all those activity happens in the real time. Actually, we try to purchase at the same time, in the same process it is being done. The rest of the process, that is identifying the address, taking the transaction, that is transferring the money to the that particular e-commerce site, and all these activity is being done at the those particular interval of time. That's why it is treated here as a real time goods dealing. And when we are trying to exchange any goods through the money on the network, at the particular time, that goods dealing comes under the real time goods dealing process. And this is e-commerce site is an example of real time. That's why I'm given an example as a real time. Another is consumer enterprises. There are so many consumer enterprises are there. Consumer enterprises here refers to different activities that is being performed today. Earlier it was performed offline, that is manually they have to user or customer have to go for consumption or to get the goods or get the whatever you want to consume from the enterprises. Now through the internet, consumer enterprises has been come on the social media, or that is social sites, where different consumers try to utilize the enterprises activities. Another is application of observing and describing inside IT systems. Means what is happening in the IT systems, information technology systems, observing and describing. All this activity can be done, and this is treated as an application of data stream here. These are the four activities which are frequently being utilized in this internet world. Now we will talk about the data stream management system, which is a very important topic in this data stream for data analytics subjects. When we are talking about the data stream management system, these are the different activities on this architecture. It has been shown here in this management system. It has been shown here. That is, what are the activities will be performed. These are the numbered here. That is number 1, 2, 3, 4, 5, and 6. These are the 6 activities these being performed on the this is data stream management system. The first one refers to the variety of data, that is different types of data which is being inputted to the system. While inputting, there are different numbers, alphabets, binary system, special characters, audio, video, everything will be come under this stream process. And what this management system do here is it classify those data at the location 2. By separating those data at a location 2, then it transfer to the stream processors. This is what activity is done in this data stream management system. Means the raw data or the input that is being transferred here, it is being separated here and transferred to the stream processor. This stream processor process those data and try to store those data in archival storage or limited working storage. This limited working storage refers to the data which are specific, which is very well identified by the processor, and which is important for the system, that those data will be stored in a limited working storage. But the other data which are being further utilized and reutilized, if it has to be reutilized, that will be stored in this archival storage, where it can be archived later on. And by archiving those data through this stream process, it will be sent to the standing queries. These standing queries actually refer to the process where it will, with the help of a structured query language, it will identify those archival data, whatever it is being queried by the client or different users. And this is treated as a number 5, and which is called ad hoc queries. Ad hoc queries used to done with the help of standing queries, by simply writing some sorts of code to find it out what are the activities to be performed on this data. And after performing, it will be presented as an output, and this will be treated here as output stream, because different varieties of data is being transferred in this data system. So these are the 6 steps which this data stream management system holds, and I will be elaborating more on this in the further. Now if you see here, I was talking about at number 1, it is input stream. So what exactly input stream does here is incoming continuous data flow, such as number, text, binary sequence, or symbols, anything it is possible. For example, sensor reading, financial tick data, IoT signals, log files, all this comes under the input streams data. That is flow of data which are of number type, text, binary sequence, or symbols. After that, when we input those data, there comes another stream input to the processor. Now what this stream input processor does here is, the data streams enter the system for processing. means it will be for processing purpose. And what it will process, each stream is directed into a stream processor for real time analysis. Because we are talking about the data analytics subject, and that's why whatever data is being transferred to the system management system, that is data stream management system, it has to be processed. Maybe it will be analyzed in real time. That's why the real time analysis is being done with the help of stream processor. Another that stream processor core here refers means the central engine that executes standing queries and process incoming data. I earlier talked about when it is whenever any queries is made by the ad hoc query, that is ad hoc client, those queries will be treated here itself, that is in stream processor, which is called core, and it get executed here, standing queries and processing incoming data. Works continuously on unbounded stream instead of waiting for complete data sets. We talked in data stream in previous previous lecture about the unbounded nature of the data stream. That's why this stream processor has a capability to work continuously on these unbounded streams. It will not wait to get whole set of data at the same time. Instead, it will work on those unbounded stream of data and will try to analyze it. Uses both limited working memory and archival storage to manage data. It will work on the both. Another component or another part of the management system is the storage components. Actually, whatever data stream is being transferred or being processed in that management system, that has to be either stored somewhere else or it has to be processed in the real-time activity. So in order to process or in order to store those, the components which is required is limited working storage and archival storage. There are two storage system was there, that is limited working storage and archival storage. Limited working storage refers to the small temporary memory for recent or intermediate data. As I talked about that whatever active ad hoc query is being made, it is possible that it will be of temporary nature, or it will be a small processing of the data activity. Those limited working storage data will be managed here. That's why it is treated here as a, it comes under the limited working storage, and a small temporary memory for the recent intermediate data, it is being utilized over there. Archival storage refers to what? It is a long-term storage for historical or less frequently accessed data. This is the main difference between these two data storage system, that is limited working storage and archival storage. Archival storage stores the data which will be accessed in the later stage or in the time when it is needed in future. And now we will come to the another system part of the system, that is ad hoc queries. This actually ad hoc queries refers to what? One demand query submitted by the user in the real time. When we are trying to work on the management system for the data, those are stored in the limited working storage. These ad hoc queries can be made here. On demand queries can be submitted here. We can see in this data stream management system architecture, that is this ad hoc query, that fifth standing queries is being made here and is being processed by the stream processor, and this archival storage and limited working storage is given here. Archival is a we can say future storage system which will be utilized in the future data that is being stored, and limited working storage which has a limited amount of data to be used. These queries are combined with standing queries for execution on live data stream. This is very important. That's why ad hoc queries is made here, means it is in real time, and whatever query is made, it will be made through this execution and those queries will be executed in the live data stream. And finally we will get the output stream, that is the results of the processed queries, and output is continuous just like input. That's why this is a this data stream management system is treated as a stream management system means continuous input is being given and continuous output is being taken on the those system, generating real-time insights, alert, analytic dashboards, monitoring results. All these are the activity that is being passed to the output streams. Whenever input streams comes, it will be processed and passed to the output stream in the same manner as the volume, velocity and variety of the data is being inputted over there. Now comes the DSMS architecture. As earlier I have talked about, it is the architecture itself. This is the further elaboration of that architecture, and it has been explained here in a layer format. Means what are the different layers of the DSMS architecture. First layer is a data source layer. Now second one is data ingestion layer. Third one is processing layer. Fourth one is storage layer and query layer, and visualization, reporting layer and integration layer. So these are the 6-7 layers in this data architecture. We will discuss here one by one. This data source layer actually the DSMS system is data source layer. As its name suggests, it comprises of all data source which will included as a sensor, social media, feeds, financial market, stock market, etc. Means all the data that is being utilized here. This will be treated as a data source. And in the layer capturing and parsing of the data stream happens basically. It is a collection layer which collects all the data. As we talked over there in architecture, that is management system architecture, that is input is being done over there. Different data is being inputted in a stream. In this data source layer, we have to, we can say here that these are the source through which the data is being generated and being utilized in that data system management system, data stream management system. Now ingestion layer actually it acts a bridge between data source, as we talked in data stream management system, that is point number 2, where the inputted data is being managed. These layer act as a bridge between data source layer and processing layer. The main purpose of this layer is to handle flow of data. That is what? That is where the data stream being segregated. Data flow control will be done. Data buffering and data routing will be done. That's why it is called data ingestion layer. And in third step, that is processing. Stream processor was there, where we used to process the data. In this processor layer, the layer considered as the heart of the DSMS architecture. That is data stream management system architecture. It is a functional layer of data system and data stream management system application. It processes the data streams in real time. This is very important. The example of real-time data processing engine is Apache Flink. Apache Storm is an example platform where real-time data is being processed. The main function of this layer is to filter, transfer, aggregating and enriching the data stream. This can be done by driving insights and detecting patterns. Storage layer is there. NoSQL database is being considered for storing. Query layer is there, similar to SQL query structure. We used to make a query on this, and this can be done through the different application on a big data. I will give you the example of Hadoop as a platform in which HDFS file system is there, and those file system on the HDFS file system platform, HBase and Hive is there. Hive and Pig is there, is being installed, which helps to make query and store the data. Similarly, in query layer, it is being done over there. Visualizing and report analysis. For report analysis, this layer provides tools to perform visualization like chart, pie charts, and histograms, etc. Means statistical data analysis is being done here, and reports is being made here. Integration, this layer responsible for integrating DSMS application with a traditional business intelligence tool, data warehouse, machine learning application, and natural language processing application. It helps to improve already present running applications. It provides a scalable and fault tolerance application, which can handle huge volume of streaming data. This layer can change according to business requirements. So many included all layers on some of the And this is what today we have discussed on the data stream topic of the unit 3. And we talked about the data stream management, we talked about the data stream application, we talked about the data stream advantage and disadvantages. Also we talked about here today about the data stream management system and architecture of the data stream management system. And next unit we will talk about the R programming and its utilization, its applications. And in fourth unit we will talking about the different clustering features and frequent item sets, which is being how to analyze those data which is being studied here. Thank you.